Back a few pages, so we're going back to a nice easy piece this morning. We're going to be drawing graphs. And if I drag you all the way back to page 220, please. Drawing a curve. Y is equal to the sine of theta. This is page, sorry, it's gone on to page 221 now. How many of you have seen these graphs being drawn before? How many haven't? More to the point, how many haven't? A couple of you. So to draw a graph, we do exactly like we did at Junior Cert for the quadratic graphs, etc. You simply do yourself a little grid, and you find various angles. So 0, pi over 2, pi, 3 pi over 2, 2 pi, whatever it might be, and you find the value of the sine of theta. Now they have it done there in the book nicely. And you see the way the graph looks. So the graph looks something like this. Just, okay. And it just goes on, and this is 0, this will be 1, and this will be -1. Again, emphasizing the idea that you will never get a value for sine above 1, or you will never get a value for sine below -1. It fits, I would expect that to be the case. Those people who haven't done trigonometry, when you come in on Tuesday, will you just go along the edges here so that I can, if we get a chance, I can go down and see what bit of work you're doing or whatever, in order to see if we do something during class, I can see what you're at, please. So all we have done there is I have drawn a graph like I would have at Junior Cert. I would find the various values. So 0, 1, 0, -1, 0. And I would plot the graph. So that's a fairly straightforward idea. Now, as I said, that's done perfectly in your book. They have done. Now, they have pi over 4 put in, but I don't know how they can put in 0.7 on the graph. It'll be hard to find. It's actually 0.7071. I don't know how they'll actually find that, but that's why I didn't put it in there. But you could put it in. Now they've actually drawn the graph there, they said, to 1 decimal place, so they're doing a reasonable job of that there. So are we happy enough with that? As I said, I'm more concerned about the people who haven't this done before. Now this graph is called a periodic graph because it repeats itself. As you can see, they have a better picture in because they've it run up as far as 7 pi. You can see it in the book. It runs as far as 7 pi. And we can see it's periodic in the sense that it repeats itself. And the period of this graph, I should have put in numbers here, sorry, I put in this first. 0, pi, 2 pi, 3 pi, 4 pi. So the period of that graph is 2 pi. In other words, it repeats every 2 pi. Now, this is a popular enough kind of question in the exam now. It's popular enough. And they link this with calculus big time. So that graph has a period of 2 pi. It repeats every 2 pi. And there's another term that we need here. We need the word called range. And the range is the highest and lowest value of the graph. And in this case, we always put in the lower one first, put in a comma. So the range there for this graph is from -1 to 1. It goes from -1 up as far as 1. And they're the big two. Lovely little 5 marks for each one of those the day of an exam. Should you get a periodic graph and they'll ask you what's the period, what's the range, you can tell from the picture. You can pick, it doesn't have to be from, there it is beginning to go uphill, and there it is beginning to go uphill again. So you can see the period is every 2 pi. You could have worked it from here. You could have said it's at the bottom of the hill there, and it's also at the bottom of the hill there. So between the two x's is also 2 pi. So you can pick any two consecutive points or corresponding points. You all right? So the period of the graph, the range of the graph, you can tell visually what the period of the graph and what the range of the graph is. On the bottom of page 221, they have done the same thing for the cos of theta, the cosine of theta. They've drawn that graph as well. Now, I'll just draw that one in. So this is the way this one goes. Did that not so well? No, I'll take out the hill of that. That's too steep. There it is. So we have 0, pi, 3 pi, pi, 2 pi. This is pi over 2. This is 3 pi over 2. Okay. Again, for those of you who are, this is the y-axis, obviously. This is the theta axis, not the x-axis, the theta axis. So this is y is equal to the cosine of theta. And we can see, again, the range is also -1 to 1. Again, marking in with our original idea that we know that the sine or the cosine of an angle can never be bigger than 1 or -1. Never, it's always in between the two. So that's the cosine curve. So they're nicely done in your book. You can see the two of them. The period and the range again for each one of those. The sheets I gave you out this morning does this section quite well now. I think it does it better than your own book. So that little booklet that you collected at the door does the curve sketching quite well. I took those, by the way, from the texts and tests, and I think the solutions are in with them for the various questions. Here. Okay, can I roll it up there? Still a few people taking a few bits. As I said, it's in your book anyway, so nothing major. And if you turn the page, there's a slightly trickier one on the next page, page 222. There is the cosine or the tan graph. Now it's a funny looking graph, that tan graph. Up there. So if you look at it again, all they did was filled in loads of numbers. So 0, pi over 8, pi over 4, 3 pi over 8, pi over 2, etc. And the curve looked like that. So between 0 and 90, the curve goes from 0 to infinity. I'm going to roll that. Okay? Leave that little piece there. Okay, it's gone. So if you take that from 0 to 90, so we know that if you think of our unit circle, on the unit circle, just have a look at this now. There was cos and there was sine, that was 0 and 1. And tan was sine divided by cos, which is 0. And here this was 0, 1. And tan was 1 divided by the other, so tan was infinity. And then here, between 90 and 180, it became 0 minus 1. So tan, I'll put in tan in red. So tan is infinity. Tan is infinity, tan is 0, and in this case tan is 0. And then when you get to 270 down here, 0 minus 1, tan is minus infinity. I'll put it in it. Oh, geez, I didn't do that properly now. Minus in. Let's take them all out. Sorry. 0 minus 1. So this one then is minus infinity. And if you look at that in the graph, so 0 pi over 2, pi, 3 pi over 2, and 2 pi. So if you look at that in your curve there, we know that so this goes all the way up to infinity. So that's what that does there, between 0 and 90. And then if you look at it between 90 and pi, it's heading back towards, so it was down, it actually does this. Between 90 and pi, it actually does that. It heads back towards 0. Remember, tan is negative in this section, so it's starting at negative. And there's a line in there. We call that an asymptote, that line there. An asymptote, some people call it an asymptote. So it means the graph never reaches a number up there. So as that black line shoots up into the air, it never actually reaches the top. So that's why it's a dotted line. And for 90, there is no answer for the tan of 90. It's infinity. So that's why that line is there. And then the graph reappears on the other side and heads from if you look at the unit circle, it heads from tan being infinity and negative, minus infinity, back down towards 0 again. So look at it heading for 0. And then it keeps going, as you can see in the next piece, between pi and 3 pi over 2. Between pi and 3 pi over 2, you can see it again the way it is. Okay, it's heading back towards infinity again, like that. Was that a green line? Jeez. No, I've never seen this coming up in the exam. And again, at 3 pi over 2, it doesn't exist. The graph doesn't exist. Okay, so you can see that then between 3 pi over 2 and, if you look in your picture there, between 3 pi over 2 and 2 pi, it begins the whole story again. Look at it. It begins down here again. And it's heading back up again. Now, it's not a straight line, like my line is badly done. They have a much nicer version of it in the book. But you can see the way the graph is going. Now, this time, the period of the graph is actually pi. It repeats itself every pi. If you look at it, it crosses the x-axis every pi. Pi, 2 pi, 3 pi, 0 if you like, pi. So the period of a tan graph is actually pi. And the range in this case goes from minus infinity to infinity. Now, all they have done in the book there is they have filled in various numbers. That's all they've done, and drawn the graph based on that. You'll never get caught with this the day of an exam because you just fill in numbers and draw the graph. It looks very messy now there on what I have done there on the screen, because I've been trying to show you where the numbers came out of it, but you'll be hitting those buttons. You'll be just firing them into the calculator. So between 0 and 90, it's going from 0 to infinity, and then it goes from minus infinity back up to plus infinity through 0. We know that tans are positive in this section, so that's why this is up above the line here. The tan is positive, so it's going from minus infinity to 0, and then it's positive. Tan becomes positive then. So once I got beyond 180, tan becomes positive, so it's heading up in that direction. But your calculator would tell you that if you were asked to draw that. Now, it'll need you to sit down at the weekend and have another look at those. Right. I really want the people sorry, I know I did that too early now. Sorry, I know some people are taking that. But it's there in your book. So I'm sorry, come back to me if did that. Okay, right. What's the whole idea of this? Why the hell are we doing this? The reason we're doing this is if I have a curve like this, actually no, if I have a curve like this, well, it won't look like that if that's the curve. It will look more like this. I hope you have a quick look at that and say, God, yeah, he's right. That's what it would look like. The factors would be x plus 2 by x plus 1, so the roots would be minus 2 and minus 1, and it would hit the y-axis at 2. I've said that very quickly. I hope you realise that. The factors will be x plus 2 by x plus 1, so the roots will be minus 2 and minus 1, and it'll hit the y-axis at plus 2. So that's pretty consistent with what I'm talking about. So if I wanted you to work out where will x squared plus 3x plus 2 equal to a half, if I asked you to do that, you can do that by algebra. You can just bring over the half, make it 1.5, hit the minus b, and off we go. Easily done. Alternatively, if I have a graph drawn, I just go to a half. This is my y answer. I want to know what x's will make that be a half. So I go to a half here. I'll draw a straight line across, and wherever it hits the graph, that will be my answer. So that's the whole purpose, really. The only reason you're learning how to do any kind of graphs at Leaving Cert or at maths is so that you have two alternative ways of doing the same question. The graph is doing it via picture. The red box there is doing it via algebra. And that really is the only reason that you're bothering with graphs, is that you can visually see an answer to a question. Now, they won't really accept it. When they want you to do algebra, they won't accept the graphical version. Sometimes they ask you to verify your answer. They give you this, and then they say verify your answer algebraically, and you'll try something like that. But that's the whole purpose of something like this. Okay, so we can actually use our little bit of algebra that we learnt at Junior Cert, or we also did this at Junior Cert. You know, also I can actually ask you to find f of minus 1. No, that's too hard. F of minus 0.5. At Junior Cert, or even at Leaving Cert, you would have filled that in there. So you just fill it in. You know that x is minus 0.5. Fill it into the graph and see what you get. Alternatively, I can come over here and go to minus 0.5, come up to the graph and come across, and that'll give me the same answer. So the yellow bit there is the yellow bit there, and the green bit is the green bit. So we can use the graph to tell us things. So to be honest with you, you're either going to have to know the x number to find the y number, or the y number to find the x number. Here I know that in the red box, I know the y number, and I can go to the graph and find the x number. And in the blue section there, I know the x number. Fx is what it normally is. We're doing f of minus 0.5. So I know the x number is minus 0.5. So I go to the x-axis and go up to the graph and come across, and that will give me the y answer. That is the equivalent of filling in minus 0.5. So that's the whole purpose of graphs, that we can use them to tell us things that algebra might be a bit awkward in doing. So think of that. Always, you carry the two of them in your head together. You know, if your back is to the wall, you do the graph. If you really, really got stuck and you really, really had trouble, you think maybe I can solve whatever equation it is visually. Maybe I can, you know, even down to this, you know, solve this cubic equation. I know from experience that a lot of people, even though it's a method maths, famous method maths again, a lot of people forget how to solve the cubic equation. Who remembers how to solve the cubic equation? Hope you all do. Rory, I'm going to ask you. Correct. If I was really struggling and I didn't know how to do it, I would draw the graph of that. It would mean getting my calculator and filling in a whole stack of numbers, and eventually my graph will look something like this, and then I'll just read off my answers. Done. So that's it, done visually. They kind of don't accept that in the exam, but you could sort of say, oh yeah, sure, I know that 1 is a root now, or -1, and therefore I can maybe think about it. But yeah, it can be done. So as I said, that's the whole purpose behind it. So the whole purpose behind graphs is to bail us out sometimes in a scenario, unless they specifically ask us something. Remember, you either know the x number and you're asked to find the y number, or you know the y number and you're asked to find the x number. Think of the red box there in the blue section. In the red section, I gave you the y number, the final answer. In the other one, I gave you the x number. And you just go to the graph, to the appropriate numbers, and work your way around. Lovely, simple stuff. If you know it, obviously. But just to keep it in your head, sometimes when the pressure comes on algebraically, you think maybe I'll get around it by doing graphs. So go back to our sine graph then. So the sine of theta, y is equal to the sine of theta, and we draw a lovely graph here. It's a periodic graph, so 0, pi, 2 pi. So this must be pi over 2, and this must be 3 pi over 2. How did I know that? Well, you can see it. 0 to pi, so halfway in between is half that, so pi over 2. So there's our graph drawn. And I know this number is 1, and I know this number is -1. So, for the last couple of days, I've said to you, solve this. The sine of theta equals a half. The sine of theta equals a half. And you've been doing that using the little diagram with the unit circle and cast and all that sort of stuff. And you've worked out the various angles. So you have done this. The sine of theta equals a half. So theta is equal to the inverse sine of a half. And you've gone to the bother of this crack. And eventually you got theta equals 30 degrees. And theta equals, or 30 degrees, I'm going to write it as pi's now, pi over 6. And theta equals 5 pi over 6. And there was my two answers. So that's, if you like, I won't call it the algebraic way because it isn't really algebra, but it's solving a trigonometric equation nonetheless. That's the way you will be doing that 99 times out of 100. But we can actually solve the same question using the graph. I know the sine of theta is a half, so I know the y number is a half. So I go to a half here, I come across and I draw. Now look at how many answers I'm getting here now. I'm getting this one, I'm getting this one, I'm getting this one, I'm getting this one. I've only given you the ones between 0 and 2 pi. So there's my answer. Now you will need to have this drawn accurately in an exam to realize that that's pi over 6, but at least you know they will set you up on that, and then this one is slightly less than pi, it's 5 pi over 6. But at least now I can solve trigonometric equations without getting too bogged down in it. And that's the purpose of this. All I have to do is draw a graph accurately, and then you're giving me the y number, so therefore I can do the other one. We all right with that now? Talk to me now if you're having trouble with that, because this is important. You know, later on we'll be talking about this as being like the tides in Galway. And I want to know what time is the tide at its lowest and what time is the tide at its highest. It's visually the same thing. So any questions on that now? Really important now this. Really, I keep saying that every day, but that's the way it is. Parking that for a second. Sunday at 12 o'clock. Who has never used Zoom before? Right, you need to download Zoom app. And tomorrow evening at 6:30, I'm doing a trial run for those who have never done Zoom. I'm just going to do a 1-minute Zoom class, 1 minute, just that you can hook in. So I'll be sending you via your classroom email, I'll be sending you an invitation code plus a passcode. I think the invitation code is about 6 digits, and then a pass number is about 3 or 4 digits. And I'll send you on that, and you just type it into your Zoom thing, and lo and behold, I'll be there. So it's only for about a minute, just to make sure everybody hooks in. 6:30 tomorrow evening, 12 o'clock on Sunday for logs. You know, if you have a bit of time, have a quick look at the logs. Anyway, that's that. So we now know why we're bothering to learn about graphs. because sometimes it can bail us out. It can help us to do some of these questions. And as you can see, it goes on forever, you know, so I can pick out the ones, all the other ones. There is another advantage to this. If I said to you, without your calculator, look up the sine of 15 pi. Without your calculator, look up the sine of 15 pi. Well, you can go on and on and draw this all along. But if you think about it, this repeats every 2 pi. So 2 pi, 4 pi. 2 pi is there, 4 pi is there. You can't see that. 2 pi is there, 4 pi is there, 6 pi is there, 8 pi is there, 10 pi is there, 12 pi is there, 14 pi is there. So 14 pi is at the start of every hill. So this might as well be 14 pi, where I'm now putting in the black circle. Therefore, I need to go another pi. There. So 0. Sine of 15 pi is 0. Without a calculator, I was able to figure that out. So every 2 pi it repeats. So I just divide 2 into 15. That's 7 full repeats. So in other words, I'm now, for the next, after 14 pi, I'm now beginning the whole story again. So I'm beginning at the beginning again. So at 14 pi, I was beginning, it was 2, the period is 2. So I'm looking for 15, so that's 7 full repeats. 2 into 15 goes 7 full times. And 1 remainder over, so 1 pi left over. So where I'm really saying that the sine of 15 pi is the same as the sine of pi. Okay, so I'm going to ask you this. What's the sine of 105 pi without a calculator? You can always check your answer with a calculator. The sine of 105 pi. I'm going to check it with the calculator while you're doing that. Don't forget, if you're checking with your calculator, you must be in radians. So you do 2 into 105 and see what your remainder is. 2 into 105, and it's the remainder you're interested in. So I think we're getting a remainder of 1 again. So you're actually looking up the sine of pi then instead. So it's also 0. 2 into 105 gives you 52 and a half. Now that half is half of a full period. Now a period is 2 pi, so a half of a full period is pi. So you got 52 and a half when you divide it. That half is half of a full period. And a full period is 2 pi, so half of a full period is pi. So I'm looking up the sine of pi instead. Okay. One thing I forgot to mention to you, if you go back please to page 221. Now, what I'm going to say now in the next 3 or 4 minutes is important. If you look at the sine curve, a sine curve will always begin here. It'll start going uphill from the origin. Or not exactly the origin, I'm sorry. It will always start going uphill on the y-axis. Sometimes the graph will be higher up or lower down. You know, sometimes you'll get a sine graph beginning here, but it will be going uphill from there. So sine curves will always do that. And you can see that from the picture. Cosine curves will always be at their maximum. Again, so if I'm drawing that, I kind of begin from here. So that's the way it goes. So cosine curves will be peaking on the y-axis. They will peak on the y-axis. Now, peak is probably the wrong word to use because they can sometimes trough. I'll show you what that is in a minute. So cosine curves, if you look at the picture, the cosine curve will be starting on the y-axis if you look at page 221. Now, you probably need to write that in your book, you know, on page 221 to remind yourself of that. Now, the black graph there is the sine of theta, and the red graph is minus the sine of theta. So when I said to you it always starts to go uphill on the y-axis, it might be going downhill if it was a negative curve. So negative curves will go the opposite direction. So the red graph there is minus the sine of theta. And the same thing then for the cosine. I'll make that a little bit smaller. Oh, sorry. So that'll be doing that. Alternatively, it could be doing this. So the black one is the cosine of theta, and the red one, so minus. Sorry, that last one is wrong. That last one is wrong. I was drawing the cosine graph again. It's peaking on the graph, so it'll be like, kind of like that. That will be the cosine curve. And the sine one of them will be the image of that, the actual mirror image of that, so it'll be going that way. So that'll be the minus the cosine of theta. So it will be the mirror image. So it'll either be on its way down from the top or it'll be on its way up from the bottom. A cosine curve will either be on its way down from the top or on its way up from the bottom. A cosine curve. And a sine curve will either be just beginning to rise up the hill or just beginning to head down the hill. So just be aware of the difference between the two. You probably need to write that in English somewhere on that, you know, on the two graphs. So if you write, let's say, it might even be worth your while to do a mini sketch of that beside the two curves there. So this one starts on the y-axis to head up or down. Up or down. I'll put the word up or downhill. That's what I'll put there. And this one here. So on the cosine, it'll start on the y-axis from the top or the bottom of the hill. Now that's an important little piece. It's not overly important, but it is nice to know that at least you can see things in advance. You know, if we were taking the tides in Galway and I was saying the tide at low tide, I know it would be a cosine graph I'd be drawing, and I know it would be a negative cosine graph because it's starting from low tide. So I know that if I was to represent it on a graph, you know, a tide coming in and coming out will look like that. But if I know it's starting from low tide, then I know it's at the bottom of the hill. It's now going to go up and down again. So that kind of information is handy to know. Now, if you have numbers, you'll be able to figure it out for yourself. So we have a couple of little bits and pieces. Sorry, no, people are still taking stuff down. We have a couple of bits and pieces there about those curves that we're able to do various things with them. Well, we haven't actually done anything with them yet, but we will be able to do various things with them. If you look on page 222, look at the way that question is phrased. 222, worked example 714. and they have a lovely graph drawn for you. Now, you would have to go to the bother of drawing that graph if they didn't give it to you. They're giving you a lovely graph there. And they're saying, find 3 angles with the same sine value as pi over 4. Whoa. So, find 3 angles with the same sine value as pi over 4. Now, if I was to do that from algebra, the sine of pi over 4, they want 3 angles with the same sine value as pi over 4. So in my case, I look up my calculator. I don't need to. It's 1 over root 2. So they want 3 angles with the same value as that. So here I have that sine x equals 1 over root 2. So here I am now trying to go backwards. I know the answer is pi over 4. So I would have to do this. The sine of x is 1 over root 2. So here's my angle reference, positive and positive. This is me doing it now by algebra. This is not the way that they're doing it here in the book. So x, it turns out to be pi over 4. So this then is pi over 4, and this is also pi over 4. That's my usual thing that I'm doing. So my real angles then are, so x is equal to pi over 4 plus 2n pi and pi over 4, or not pi over 4, 3 pi over 4 plus 2n pi. I hope you see that now. That's what we were doing all week. You know, finding my reference angle, my red dot, working it out, putting it in, and then working out the green bits. So x is pi over 4 plus 2n pi, and x is 3 pi over 4 plus 2n pi. Think of now what the question was. The question said, find angles which have the same sine value as pi over 4. Now, I have to find out what the sine value of pi over 4 is first. It's 1 over root 2. I looked up that in the calculator. Then, what other angles would give you the same answer? So now I have to work backwards to see what other angles are involved in this. So then, you would do the usual. You let n equals 0, so you get x equals pi over 4. Well, that's not another angle, so, and then here x is 3 pi over 4, so that's one angle. And then if I let n equal to 1, I'm getting pi over 4 plus 2 pi. I should have got a common denominator there because we always did that. I think it's 9 pi over 4. Now, I should have given you the common denominator there, but I've just done it because it's a short one. And this is 3 pi over 4 plus 2n pi. That's 8 and 3, 11 pi over 4. Let me go out here with this. No, I'm going to rub it out altogether because that's not the way I taught you to do it, so I'll stay with it. Stay with what I showed you. So x is equal to pi plus 8n pi over 4, and x is equal to 3 pi plus 8n pi over 4. That's what I showed you how to do it, by getting rid of the common denominator. And then I let n equal to 0, and I get x equals pi over 4, and x equals 3 pi over 4. And nice and steady, no panicking. X is equal to 9 pi over 4 when I let n equal to 1, and x is 11 pi over 4 when I let n equal to 1. And there's my 3 other answers that they were looking for. So find 3 other angles that have the same sine value as whatever the sine of pi over 4 is. Find 3 other angles which have the same sine value as the sine value of pi over 4. So I had to first of all find out what the sine value of pi over 4 is, and then I have to work backwards to get all my various angles. And I use the general polar form because that's the general polar form is, you see, there was no mention there of between 0 and 360. So we use the general polar form when we're not doing, well, we use the really you use the general polar form the whole time if you want. It doesn't actually matter. Is that okay, that particular way now? Think about what they asked again. Find 3 other angles that have the same sine value as the sine of pi over 4. So I had to first of all work out what the sine of pi over 4, what angle are we talking about? And I established there was 2 answers, pi over 4 and 3 pi over 4. So the blue box is the answer to the first bit. And then all I have to do is find 3 angles involved in that. By the way, the blue box is every angle that has the same sine value as pi over 4. Every angle in the world. It's just a matter of which n you're going to use. You can use any n you like. Now, in reality, the way it's done is in the book. The graphy version of that. So the graphy version of that looks like this. Here's the graph. It's a sine graph. There we go. And they said find 3 other angles. So this is the y, and this is the -1, and these are our various numbers: pi over 2, pi, 3 pi over 2, and pi. The same sine value as pi over 4. So look at how we do this. There's pi over 4. I put it there to make it easier for me. There. So that's the answer. So I'm looking for 3 other angles that have the same one. So I just go straight across and come down and come down and come down. So I started on the x-axis at pi over 4, and I went up and across to find the value we're talking about. And then shoot straight across. That doesn't look very straight, but shoot across to find all the other angles. So I started at pi over 4. I want to know what the sine value of that is. This is a sine curve. And I found where it was on the y-axis. And then I want what other angles will give me the same y number. So draw a line straight across. I now know the y answer, and I'm looking for the x answer. Really, that's what we're saying here now. I now know the y answer, and I'm looking for the x answer. So that's the way they wanted you to do that question, really. They've given us the graph. And they have done the same with part 2. They've given you a cosine curve on the next one. Cosine curve. And they've asked you to find 3 with the same cosine value as pi. And the cosine value of pi is -1. And you can go across. By the way, you can go backwards as well. You know, you can go left as well. The graph doesn't begin there. The graph is actually back here as well. The graph is back along there as well. Okay, there was something I wanted to say about that now. Flashed into my head a minute ago. What was it? Oh yeah, I know what it was. That angle there is 30 degrees. This angle down here is 330 degrees. But 330 degrees, we always measure angles anti-clockwise. So we always go that way to measure an angle. So 30 degrees, 330 degrees. But if we choose, we can actually go this way. And if I go that way, we write them as negative angles. So 330 degrees could also be written as -30 degrees. Now, rarely, some books use it and some books don't. But if you see -30, the minus is not the significant bit. The minus is only telling you which direction it was measured in. So you know it's 330. But you can still type it into your calculator as, I've got to change this into degrees now. You can still type it in as, I know the cosine of -30 is going to give me a positive answer. Because it should. Because -30 is down where cosine is positive. If you type in, make sure you're in degrees, if you type in the cosine of -30, you will get a positive answer. The minus is not going to affect the number that you're going to get. The minus does not affect it. The minus is just telling the calculator, I'm writing in -30, so you change it to 330. So the calculator in its battery is changing it to plus 330 and typing it in there. So the -30 is not there for any other reason other than which direction you measure that in. Are we all right? Okay, get rid of that. So, what are we doing on time? Nearly there. Sometimes they will get you to draw something like this. Y is equal to 2 sine theta. And what you do is you do out a grid. Now, I'm going to show you how to do. I better tell you about these things on the grids. I'll write a couple of these first to let you see these. Y is equal to 3 cos 3 theta. Y is equal to 4 sine 5 theta. Now, the thetas have a period of 2 pi. The period of this one will be 2 pi over 3. And the period of this one will be 2 pi over 5. So the period is always 2 pi divided by whatever number is in front of the x or the theta or whatever it is. So the period of those three graphs is 2 pi, 2 pi over 3, 2 pi over 5. The period of the curve will vary. And what the numbers in front do, I'll have to reduce that to get it out of the way, that thing there. What the numbers in front do is what they do is they change the range. So this range goes from -2 to +2. This range here will go from -3 to +3. And this range here will go from -4 to +4. They are the periods and the range of the graphs. As you adjust the numbers around the sine of theta, your range and the period of the graph and the range of the graph will change. Notice the way I put the minus number first when I'm doing the range, and I do the plus number second, and we use a kind of a square bracket on it. Right. What does that look like when you're going to draw a picture? Two sine theta will look exactly like a sine graph should. It still repeats every 2 pi, so there's my period bit done. But the range is going to go from 2 to -2, so it doesn't do a major thing to it. The period still gets the same. The period is still 2 pi, but the range goes up. Remember, the maximum value of this is 1, so the highest 2, if the maximum value of the box there is 1, then 2 by 1 is 2. That means you're going to reach a top 2. And if the lowest value of the box bit is -1, then 2 times -1 is -2. But that's what that graph will look like. It will repeat every 2 pi. Now the other graph, I'll do the bottom one first, 4 sine 5 theta. So here is 4 sine 5 theta. This is what this will look like. This is going to repeat every 2 pi over 5. So therefore I know that's where it's coming back home again. So it's going to do this. It's going to repeat every 2 pi over 5. So the period is 2 pi over 5. And the range is the number in front. So the top value there is +4 and the bottom value there is -4. The period and the range. What's half of 2 pi over 5? Half of 2 pi over 5 is 2 pi over 10. You just multiply the bottom number by 2. The bottom number by 2 now. So you get 2 pi. It's like multiplying by 1 over 2. So 2 pi by 1 is 1, 5 by 2 is 10. So I know that number there, that even though it doesn't look like the middle of the graph there, it's supposed to be. That's 2 pi over 10. And if you think about it logically, 2 pi over 5, half of it must be 1 pi over 5, which is that. So that's that. That's the effect of that. And what was the other one again? 3 cos 3 theta. Now this is a cos curve, and it's repeating 3 cos 3 theta. It's repeating every 2 pi over 3. So there's 2 pi over 3 there. So there it is. It begins at the top of the hill. Oh Lord, that's too high altogether. Oh, it isn't too bad. Okay, it does that, top of the hill, and then it comes down, and it goes back. Oh Lord, sorry, that's all gone. Forget that. I'll begin that a bit lower because it's going to take up a lot of space. But that's what this does. Still that right there, made that too big. There. So it repeats every 2 pi over 3. The graph repeats every 2 pi over 3. And the highest value it has is +3, and the lowest value, my graph is completely off scale, -3. But I know it's a cos curve, so it's beginning at the top of the hill. The next top of the hill will be at 2 pi over 3. But look at what I always do to try and get a decent picture, is I begin my curve before and reach the peak. You know, it gives you a nicer look at the thing. You can see it happening, and you can continue it if you wish. And so what's this number here then? You can work out what this number here, the middle of the graph will be there. That would be pi over 3, half that thing there. All right. Now, I'm going to show you this, how to draw one of those graphs. How to draw one. Very quickly, I'm going to show you this in 2 minutes. If I was asked to draw the sine of 3 theta, how would I know what numbers to put into the grid? Because sometimes if you put in pi over 2, by the time you've typed in, you'll get rotten numbers to type in. So this is what I say to people to do. I know that graph is repeating every 2 pi over 3. So that's 2 pi over 3 there. That's 2 pi over 3. Half that is pi over 3. Half that again is pi over 6. And if you go up, so if you go up in sixths. So that's pi over 6. What's the half of this? Now, if you have a calculator, you can type in pi over 3 plus 2 pi over 3 and divide by 2. So this is actually pi over 2. If you add pi over 3 and 2 pi over 3, there's whatever it is in the difference. That's pi over 6, 2 pi over 6, and 4 pi over 6. So in the middle is 3 pi over 6. But if you type it into your calculator, if you like, that's 2 pi over 6. And that's, you can see it there yourself, that's 4 pi over 6. So you're getting 3 pi over 6, which is pi over 2. And you can work with that. And then they're the numbers I would use on my grid. So I would do this bother first. That's only a sketch. That's only in my head sketch. That's not a proper sketch because I don't have the proper numbers. So what I would then do is, that's the grid I would use then. 0, pi over 6, pi over 3, pi over 2, 2 pi over 3. And work with those then. And fill those numbers in. Sine 3 theta. I know I'm rushing this now. And they're the numbers I would fill in. And then I would draw a proper graph. And that's, I know I've rushed that now, and there's probably a couple of mistakes in it there with regard to numbers and stuff, but you can try it. I'm going to ask you to sketch a couple of those for tonight. So I'm going to ask you to sketch. Now, sketch, this is page 228. I want you to do question 1, and I'll get you to do the first 5 parts. Part 1 to part 5. And on the sheets, you know those sheets that I gave you out this morning? Those sheets I gave you out this morning. There's a page 70 on those sheets. Page 70. I want you to do every second one of those questions. On the loose sheets I gave you out this morning. Okay, that's it. If I can get this to stop.